In this screencast, we're going to discuss quadratic functions based on finding the vertex. And it turns out that if I have a quadratic function in our old familiar form of ax squared plus bx plus c, well, the x-coordinate of the vertex, which we usually label as h, is just negative b over twice a. And then to get k, you just plug that number into the function and you've got your y-coordinate of your vertex. So remember, to find the vertex, if you have an equation in this form, just do negative b over 2a. Then plug that number into the function to get k. So let's do it with this function. So I've got that b is 2/5 and a is negative 1/3. So h is negative b over 2a. So that's negative 2/5 over negative 2/3, which is negative 2/5 times negative 3/2, and my 2's cancel, and I'm going to get positive 3/5 for h. All right, so how do we get k? Well, we're going to put 3/5 in for x. So f of 3/5 is going to be negative 1/3 times 3/5 squared plus 2/5 times 3/5 plus 4. All right, so that's negative 1/3 times 9/25 plus 6/25 plus 4. Okay, that's going to be negative 3/25 because 3 goes into 9 3 times, plus 6/25 plus, okay, 4 over 1 to get a common denominator. 4 times 25 is 100/25. So I get 3/25 plus 100/25, which is 103/25. So our vertex is h comma k equals 3/5 comma 103/25. Now let's do a problem going in the other direction. What if I already know the vertex and a point that's on that parabola, and I'd like to get the function that graphs it? Well, f of x is a x minus h, and there's h squared plus what? Plus k. All right, and I know that when x is 0, f of x is 1. So 1 equals a times 0 minus 2 squared minus 3, which is 4a minus 3 equals 1. Add 3 to both sides. 4 equals 4a, so a is 1. So our function that has that vertex and contains that point is 1 times x minus 2 squared minus 3. Okay, so here's an application. The path of a punted football follows a quadratic function h of x equals negative 8 over 125, x plus 5 squared plus 40. So basically, h of x is the height of the football, so it's going like that. Okay, and x corresponds to the horizontal distance in yards. So x is how far the football is going horizontally, and h of x is how high the football is. Okay, assume x equals 0 corresponds to the 50-yard line, so it's right in the middle of the football field. Find the maximum height the ball achieves. Well, the maximum height is going to be your vertex, right? And so remember that h equals, well, we've already got in standard form, don't we? It's right there, h and k. So h equals 5, k equals 40. There's our maximum height. 40 yards in the air is the maximum height. Find the horizontal distance the ball covers. Assume the height is 0 when the ball is kicked, and it's 0 when the ball is caught. Okay, so I'm going to set the function equal to 0 and solve for x. So 0 equals negative 8 over 125, x plus 5 squared plus 40. I'm going to subtract 40 from both sides. I'm going to multiply both sides by negative 125 over 8. And that ends up giving me 625. I'm going to take the square root of both sides, and the square root of 625 is plus or minus 25. Okay, so x is either negative 25 minus 5, which is negative 30, or positive 25 minus 5, which is 20. Now remember, we've got a football field, right? And 0 is at the 50-yard line. And so we're going from negative 30, so we're going back here. This is negative 30 this way, so we're at the 20-yard line. And forward 20 is where the ball is caught. So I go forward 20, and that puts me at the 30-yard line here. Okay, so basically we're covering 30 plus 20, which is 50 yards. So the ball covers 50 yards distance.